In this lecture, we're going to learn about Decltype and the trailing return types. Decltype is a mechanism we have in C++ to deduce the type of an expression. And this is easier explained by looking at a simple example. For example, here we have an stdc out statement that is going to print the size of something. And the syntax we use to do that, we say size of, and we put in our pair of parentheses that live within these two guys. And to do that, we use the syntax here. We say size of, we put a pair of parentheses, and inside these parentheses, we're going to put in a Decltype expression. We say Decltype, we put a pair of parentheses, and inside those parentheses, we put the expression whose type is going to be deduced by Decltype here. This is what we should say. So how does this really work? This is going to grab the type of an expression and give you a chance to use that to declare other types. For example, this is going to deduce the type of whichever type is larger in this expression. So if we look at the variables we have in here, A is of type int and B is of type double. So B is larger. This is going to be deduced to be the type of double. And we can use this expression to declare other variables. So if we go down here, we're going to see that we can use this to even declare other variables. So what we have on the left here is going to be our type. And now that we have the type, this is going to deduce the type of this expression here. And this is going to be the type of this C variable here. And we can print it out and really do crazy things with it. So you might think, why would I want to do things in such an indirect way? But sometimes in your C++ program, you can have some crazy logic so that you don't really have easy access to your type anymore. And this is going to happen especially if you are doing a lot of template programming. This is going to come in handy sometimes, and you can use this to really make things work. But we are exploring this here in this lecture because we're going to use it to make our auto-type deduction with templates really easier. Okay, now that we have Decltype introduced and we know that it can be used to deduce the type of an expression, one might think, can't we use this to do a function that deduces the return type from an expression and write something like this? So we're going to use Decltype as our return type here. This is our return type. It's going to deduce the return type of this expression we have in this parentheses. And we're going to use this as a return type. And one might think that this is going to work, but we're going to get a compiler error if we try to do this. The reason is A and B are declared in the parameter list to the right here. Let's underline this. This is where A and B are declared. But if we try and put them to the left here in the return type, we're going to see our Decltype expression here before we hit these two guys. And we're going to get a compiler error because the compiler processes things from left to right. So it's going to see the Decltype expression before it sees the parameter list. And by the time we hit Decltype here, A and B are going to be undefined. That's why we get a compiler error. Okay, so this is the problem we have here, and we need to fix it. One fix we can really do is use Decltype as a trailing return type. And a trailing return type is a return type that you specify after the parameter list. And the syntax to do that is to put a dash and a greater than symbol here and say whatever return type you want to specify. And when you do this, now we need to specify some kind of return type to this function template here. Because if we don't have a proper return type, we're going to have a compiler error. That's why we put the auto keyword here. But the auto keyword here is really not for return type deduction. It is just a placeholder for the return type that we are going to deduce with Decltype here that we are using as a trailing return type. I realize these syntaxes are getting complicated and cryptic as we move forward, but we really need to look at this because you're going to need this, especially in modern C++ development. And this way of doing things has a benefit because if you want to split your code into declaration and definition, this is going to give us a compiler error, as we have seen before, if we are doing bare auto return type deduction like we have here. But if we are using Decltype as a trailing return type, this is going to allow us to split our code into declaration and definition, as you see here. This is the declaration. Down below main, we have a definition. And this is going to work because now the compiler can see the return type through this Decltype thing here. And it doesn't need to look at the entire definition to know what it is going to deduce for the return type. And this is going to work if you really need to split your code into declaration and definition. Now that we have really seen this, let's head to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is Decltype and the trailing return types. We're going to learn about this. We're going to grab our template files pretty quick. We're going to put those in place and we're going to open this up in Visual Studio Code. Let's drag and drop here. And we're going to have our folder opened up. We're going to close the left pane here and clean things up a little bit. And the first thing we want to explore is Decltype. This is a mechanism we have in C++ to be able to deduce the type of an expression and use that in our code. For example, here we can try and look at the size of Decltype and use the expression to compute the maximum between A and B. We have seen this like a gazillion times by now. What this is going to do is going to deduce whichever is larger between A and B because they are the variables involved in this expression. A is of type int, so it's going to take 4 bytes in memory. B is of type double, so it's going to take 8 bytes. So this is going to deduce this type of B, and that's going to be what Decltype really is. It's going to be like double here. So if we print this, we should see size of double printed out because that's what is deduced by this. So we should see 8 printed out here to be exact. So let's try and build this. We're going to use GCC as we always do. We're going to clear, bring up a terminal and clear and run rooster. You see we have size of 8 here. If we change the types here, for example, the double guy here to be a car, and change this to be a 5, for example. Now, this is going to deduce whichever is larger between A and B, and A happens to be larger because now B is 1 byte in memory and A is 4 bytes in memory. Now, if we build, we should see a 4 printed out. Make sure you really understand this. So we're going to run and we're going to say size is 4 because now this expression here, the return type of it is going to be an int. And that's what Decltype here is going to deduce. Again, Decltype is a mechanism we have to deduce the type of an expression and be able to use that in our code. So for example, we can use this Decltype expression here and use this to declare another variable. Why not? We can go down here and say this. We're going to say our type is this entire thing here. So this is going to be like we say int or car or double or whatever, like we did here, for example, here for car. So this is going to be our type. We can now put in our variable name, for example, C, and give it a value. Let's put in a 7, and we can do anything we want with this. You see that this is valid C++ code. It is going to compile. Visual Studio Code is happy. And if we pass this through the compiler, it is going to work. So we can print the value of C, for example. Let's say C. And if we build and run, you're going to see that this is going to work. Now, C is whatever is deduced for this expression here. Okay, so the build is good. We can clear and run rooster. You see that C is 7. And if we look at the size of C, let's do that. We're going to see that the size of C is going to be the size of whichever type is larger in memory in the variables that are involved in this expression here. And that happens to be int for this case here because int is larger than car. So we're going to print the size of an int, which is going to be 4 bytes here. Again, this is going to say 4 bytes. And on top here, we're also going to have 4 bytes. Let's build again to really drive this home because this is key for what we are about to do in the next few examples. Now we have C is 7 and size of C is a 4. Hopefully now you understand that Decltype is really a mechanism to deduce the type of an expression and use that in your C++ code, for example, to declare other variables like we are doing here. Okay, so declaring other variables through Decltype. Okay, we can do this. Now that we have this, we may try and use Decltype as a return type for our function templates. And we can now comment this out because we don't need this anymore. I think we can go all the way up to here. And we're going to go up and set up a function template. We're going to say template, and we're going to say type name T and a type name P. And we're going to go down here, and then Decltype is going to be our return type in our function template. So let's do that. We're going to say Decltype. That's going to be our return type. We're going to deduce the type from the expression to compute the maximum between A and B. Then we're going to call our function maximum, and we're going to say TA, the type for the first parameter, PB for the second parameter, and then we're going to return this expression here. We already know this. So we can copy this and return that for our maximum. And we might try and make this code work here. But you notice we have squiggly lines. And as we said in the slides, this is because the compiler processes functions from left to right. And it is going to see this Decltype expression before it sees our parameter list. And these two variables, A and B, are going to be declared in the parameter list here. This is where the compiler is going to set them up. So we are trying to use these variables before they come alive in the eyes of the compiler. That's why we have this compiler error here. So Visual Studio Code is going to give us what it thinks is the problem. So it's going to say A is undefined, B is undefined, because we are trying to use this before we hit the place where these two variables are declared. So no wonder we have this compiler error. Let's pass this through the compiler, and we're going to basically see the same thing. A was not declared in this scope, B was not declared in this scope. We have the same errors. We can use what we call a trailing return type to fix this problem. And the way we do that is to take this expression here, which is our return type, and move that after the parameter list here. And after the parameter list, these two guys will already be alive. A and B will already be alive in the eyes of the compiler, and we're not going to get these errors again. To use trailing return types, you use this syntax here. You go after your parameter list, you say dash, you say greater than symbol, and then you put in your return type like we have here. But notice we still have problems, because in C++, you can't really set up a function without a return type. So to really make this a valid C++ function, we need to put something in the place of the return type, and the C++ standard adopted to just put auto here just to make this compile. And if we do this, you're going to see that the problem is going to go away. Let's wait a minute. And if we try to compile, this is not going away in Visual Studio Code, but we can try and compile this program. And when we did this, we see that the problem goes away. Let's take out auto here to make sure that we really have a problem. And we're going to build again. You see that we get a problem. We don't have a valid C++ function, but if we put auto here, this is going to build. Let's build again. Now we have no problem. We have a function which is using auto return type deduction, but it is going through Decltype used as a trailing return type to our function template here. I realize this syntax can really be overwhelming for beginners, but I want you to really be aware of this because you're going to see this in your career as a C++ developer. And now that we have seen this, you're going to understand it and it's not going to confuse you. Now, if we try to call this function, what is going to happen? The compiler is going to deduce the return type to be whichever is larger between A and B. So if we call this with A and B as we have here, let's go down and do that. We're going to say auto result and say maximum. And we're going to say A and B, whichever is the maximum. If we do this and print the maximum, we're going to say result and print this out. And if we build, let's see what we get. Okay, the build should be good. Okay, build finished successfully. And we're going to clear and run rooster. Now our maximum is 9. So what is happening here? The compiler is really deducing the type to be the type which is larger here. And if we try and print the type of the maximum here, let's do that. We're going to say stdcout size of result to really understand this. So we are learning here. Don't be afraid to try out a few things. Even if you break code, no problem. We are learning. This is how we learn, by trying out things and breaking things if necessary. So let's say result here and print this out. We're going to build. This should deduce the type of int because it is the largest between A and B here. And A and B are what are used to do the expression here to deduce the return type. So did we build? Let's build again. No problem. We can clear now. The build is good and run rooster. Okay, now we are saying size of result is 9. Why is that? We didn't do things right, did we? So we're going to say size of here. Sorry for this. Can't type and talk at the same time. So we're going to build again to take these changes into our binary. The build is good. We can clear and run rooster. We're going to see that size of result is 4. So this is an integer. It was deduced to be an integer. If we change the second parameter here to be double and maybe use a double literal to initialize this, and say, for example, put in 15.8, why not? And now we're going to deduce this guy to be our type. Let's build and run and really play with this to drive the point home. We're going to clear and run rooster. Now you see that result is 15.8. It is printing here as a double. You see we have a decimal point. So the return type was deduced to be double. And we can see that here, the size of that is 8. This is really how you can use Decltype and trailing return types to make your function templates that deduce the return type easier. Another benefit of doing things like this is that we now are able to split our function between declaration and definition. Remember that for other cases where we did return type deduction with auto, we couldn't really split our function into a declaration and a definition. And the reason was that the compiler had to see the return statement here to deduce our return type. But now the compiler can see the Decltype expression here in the header of the function. Let's copy this and really make this super clear. We're going to put the entire definition below the main function. This is going to be our definition. And we're going to just leave the header to the top of the main function here, and this is going to be our declaration. Notice that we have to leave in this template keyword here, and this line here has to be there to really say that this is a function template. But now if we compile this, this is going to compile because the compiler can see the return type of this function through this Decltype expression here. And it is going to work if we try to compile code like this. So this is another benefit. If your code requires you to split your functions into declarations and definitions, this way of doing things is going to help out because we can do this with our return type deduction here, and this is going to work. This is really all we set out to do in this lecture. I hope you found it interesting. Again, Decltype is a mechanism we have to deduce the type of the expression, and once we have that type deduced, we can use that to even declare other variables as we have seen here. Another benefit of this is that we can use this to really set up a more flexible function template that uses return type deduction. And we saw that this was really cool because we could even separate our function into declaration and definition. We are going to stop here in this lecture. In the next one, we're going to see how we can avoid the duplication we have here. For example, you see we are doing this expression 2 times in this code here. And this is called repetition that we don't want sometimes. We're going to see how we can avoid this in the next lecture. Go ahead and finish up here and meet me there.